For the advanced filtering of feature data task, Ecere provided a deployment of its Gnosis Map Server as an advanced filtering service. Gnosis Map Server is a certified implementation of OGC API features, also supporting the Part 2 coordinate reference systems by reference and Part 3 filtering extensions. During the testbed, Ecere implemented support for filters expressed using CQL2, the OGC Common Query Language, while reviewing and contributing to the candidate CQL2 standard. Ecere enhanced its Gnosis Map Server with OGC API features, cascading capabilities, and prototyped the use of OGC API processes workflows to predefine filtered collections. As per the task's architecture, Ecere's advanced filtering service is a cascading service providing data sourced from other features services that do not provide filtering capabilities themselves by acting as an OGC API features client. Those cascaded external services were provided by Interactive Instruments, George Mason University, and Skymantics. The ability to filter features while cascading to other services presented some challenges, notably implementing proper paging for large datasets where not all results returned by the cascaded service will be part of the filtering service responses. The use of complex objects and array types in the cascaded datasets also required developing support for these capabilities in Gnosis Map Server. The Gnosis Map Server implementation supports GeoJSON as well as OGC features and geometry JSON as an input and output format for feature collections, and also supports returning results as vector tiles through the OGC API tile standard, including support for the Mapbox vector tiles encoding. Here we can see a single apron element feature cascaded from the Interactive Instruments service with the geometry displayed in geojson.io accessing the Gnosis Map Server instance. Here we can see a map of the JFK airport features also cascaded from the Interactive Instruments services with a default black and white style rendered in the Gnosis Map Server. Support for specifying filters using CQL2 expressions was developed in this task, including support for basic CQL2, property, and arithmetic expressions conformance classes for the CQL2 text expression encoding. Support for additional conformance classes remains to be developed. In order to properly test the implementation, the small natural Earth dataset referenced by the CQL2 abstract test was loaded as a collection on the Gnosis Map Server. Here is an example of features request for the CQL2 filter filtering the populated places collection to return only Copenhagen based on an arithmetic expression compared against the estimated population. While reviewing the CQL2 standard, Ecere made several suggestions for corrections and improvements, most of which were applied during the testbed. In the context of ongoing revision to the OGC Styles and Symbology SimCore standard, CQL2 has been considered for defining expressions to be used within selectors and parameter values for encoding style sheets. For this purpose, with collaborators from that standard working group, Ecere developed a conceptual model for expressions, including UML diagrams to which CQL2 conforms. Here we can see a feature collection cascaded from Interactive Instruments of all features for the Newark Airport filtered for parking apron elements. Here we see another feature collection for flight plans cascaded from the Skymantics service filtered by flight status and type. Here we see one feature returned by the George Mason University service from filtering the apron elements by an interpretation field value, as well as its geometry accessed from the Gnosis Map Server displayed on geojson.io. As a mechanism for a developer client to prepare different views on a collection, a filter can be configured as part of a workflow defined with the OGC API Processes Part 3 Workflows and Chaining Candidate Standard using a pass-through process. With the Collection Output Conformance class of Processes Part 3, the output of an execution can either be a dataset landing page which can contain multiple collections or a single collection. Ecere prototyped this capability demonstrated here in the Gnosis Map Server. Predefined queries could also be parameterized by deploying them as processes using Deployable Workflows Conformance class together with the Processes Part 2 extension for deploying processes. A business client can then use those deployed processes to parameterize pre-configured queries, providing additional customizable filtering capabilities. This functionality remains planned as future improvements to the Gnosis Map Server. In summary, OGC CQL2 provides powerful advanced filtering capabilities for developer clients to set up filtering rules. OGC API processes Part 3 workflows and chaining also provides a mechanism to set up virtual collections with fully predefined filters or to deploy processes for parameterizable filters for use by a business client as an alternative to a specialized search extension to OGC API features. While it was demonstrated that a filtering service can be successfully implemented by cascading to other OGC API services, in order to minimize the amount of processing bandwidth required to maximize efficiency, the filtering capabilities should ideally be located as close to the data as possible.